Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we have started the chapter SQL. In SQL, in today's session, we are going to discuss about nested queries. So let us start the session. Nested queries. What is a nested query? One query is present in another query. Suppose this is my query in SQL. In that, if I have one more query inside it, then that is called nested query. There are mainly two types of nested queries. Coming to the first one, no correlation. What does it mean? Whatever the query you are having outside, this is called generally outer query, and whatever present inside it, that is called inner query. If there is no correlation between these two, if there is no correlation between these two, then that is ordinary nested query. Sometimes we will have a correlation between the inner query and outer query. We are having a correlation between the inner query and the outer query. Now the question is, what is the meaning of correlation? Whatever the attributes we are having, whatever the attributes we are having in outer query, those we may use in inner query also. So whatever the attribute you have selected in the outer query, that we might use in inner query conditions or in selection of the records also. So this is about the nested queries. Let us discuss each of these one by one. Functions that generally used in nested queries. These are the 5 keywords, sir. Coming to the first one, in. The next one is any and all, exist, unique. Depending on the software you are using, instead of any, some people might write some also. Okay, but the intention is same. Where marks greater than or equal to any one of the listed marks, or greater than or equal to some of the listed marks. So the intention is same. We already used some of these keywords in our regular queries. Now let us discuss how to use these keywords in nested queries one by one. Coming to the first one, in keyword. Suppose we have a question that list out all the details of all the students. I need all the details of all the students. What is the condition, sir? Whose percentage is in the specified list? Whose percentage is in the specified list? 50, 92, 77. So if a student is having percentage which is equal to any one of these three numbers, then I need to display the details of the particular student. So in such case, how to write it? Select, we need to display all the details, star from student, where percentage in, we have a list. What is the list, sir? That is 50, 92, 77. That's it. So if percentage is equal to any one of those values, is equal to any one of these values, then we display the details of the particular student. Now in this example, we know the values in the list. Suppose this list I need to obtain by using another query. That means the same questions are where percentage in, here the numbers. How to get those numbers, sir? I might be interested in the percentages of girls, or I might be interested in the percentages of CSE department. So here you may write another query which we might use to get that particular list. So this is an example of a nested query. So let us see one example on this. Find the details of the boys whose percentage is equal to sum of the girls' percentage. So I need the details of the boys. Select star from student. Select star from student. Fine. Where do you need the details of all the students, sir? No, we need the details of boys only. So where sex equal to boy. And do you need the details of all the boys? No, sir. I need the boys whose percentage equal to some of the girls' percentages. Then what are the percentages of girls, sir? I don't know. So, and the percentage is equal to, or the percentage in this list, I need to write the percentages of the girls, right? If I know in before, simply I can list out the numbers. But whenever we don't know the percentages of the girls in before, what we do, sir? We write another SQL query to get that percentages. So what you need, sir? You need only percentages. Select percentage. From where, sir? You are selecting maybe from the same table or maybe another table. In this example, it is from the same table. Whose percentages you are selecting, sir? You are selecting the girls' percentages. Hope you understood it. So first we will retrieve the percentages of the girls students that will be present in these brackets. Then those numbers we use in condition of the outer query. Hope you understood it. That is the intention of the in keyword. Let us use the next keyword all. List out all the details of all the students. Fine. Whose percentage greater than all the numbers. So I need to list out the details of students whose percentage greater than all these three numbers, right? So how to write it, sir? Select. I need all the details. Star from student, where percentage greater than all of our numbers. All of the numbers 50, 90, 50, 92, 77. Right, sir? Now, if I don't know these numbers in before, what we do, sir? We write another query to get those numbers. That's it. Right? So, let us discuss that example. Find the details of boys who got more percentage than all the girls. Right? So, I need the details. I need all the details. Select star from student, right? Select star from student, where First of all, I need the details of boys, where 6 equal to boy. And what is the specialty, sir? Percentage greater than all. Here I need to write the percentages of the girls. Do you know the percentages in before, sir? No. We need to extract them from the student table. So what we do is we write another SQL query. We write another SQL query. Select percentage from student, where whose percentage you need, sir? We need the percentage of the girls only. So where 6 equal to girl. Hope you understood it. Let us go to the next one. Any keyword. List out all the details of all the students whose percentage greater than sum of the numbers. Sir, now it is not all the numbers. It is sum of the numbers. So the only difference between the last keyword and here is there the percentage is greater than of all the numbers. Here it should greater than sum of the numbers. That's it. Select star from student, where percentage greater than, right? Greater than. Here I need to write that keyword, either sum or any, sir. So let us fix any. Of what are the numbers you are having, sir? 50, 92, 77. In this example, we assume that we know these numbers in before. Now suppose we want to retrieve these numbers by using another query. Then we will go to the concept of nested query. Find the details of the boys who got more percentage than at least one girl. So first I need to list out all the percentages of the girls. Then I need to select the boys whose percentage defeats any one of these numbers, or whose percentage dominates any one of these numbers. Select star from student, where first of all he must be a boy. Right? And the percentage, it must be greater than any or some. In the bracket, I need to write the percentages of the girls. How to get the percentages of the girls, sir? Select percentage from student, where 6 equal to girl. Hope you understood it. For better understanding, I given all the 6 examples in the same genre, so that you can have clear idea about in, all, any. Hope you understood it. Now let's go to exist. What is the meaning of exist keyword? Let me check it, sir. Sir, what will happen is something like suppose I am having two relations. I am having two relations in which the first relation contains the attributes xy, and in second relation, let us suppose the attributes are w, u. Okay. So let us assume we are selecting from A one attribute where exist. In the inner, we have something. Select so and so. This is the general structure, sir. Here the main intention is what is the outer table that I need. This is my outer query and this is my outer table. This is the first one I need to identify. So this is our outer table, sir. Fine. What I do is it will take the first record. It will take the first record and it will remember the values of x and y, and it enter into inner query and it executes it. It enter into inner query. It executes it. If I get some records here, if I get some records here, if I get some records here, then I will display this particular x value. For example, suppose x value is 22, sir, something like a student rule number. Okay, by considering the rule number 22, I go and execute the inner query. The inner query may use the rule number 22, may not use the rule number 22, but exist, don't verify it. Okay, it is your responsibility to write the query clearly. Okay, so it will consider the x value 22. It will enter into inner query. It will verify whether you are getting some records for the inner query or not. If you got some records, I don't display those records, sir. I don't want them. I will display 22. Suppose I have taken the next number 44. Then again I enter into the inner query. Again I will execute the same story. If I get some records, I will display 44. Otherwise, I don't display it. For simple example, suppose in the outer query, let us suppose I am discussing rule numbers. Where exist suppose I am selecting backlogs from another table where b dot rule number equal to a dot rule number. So what does that mean, sir? In the first table I have student details. In the second table I have backlog details. So what I do is I consider the first student 22 and I list out all the backlogs. If he have some backlogs, I will display his name in remedial class. Suppose I taken some 44 and I displayed backlogs, 0 backlogs. When 0 backlogs, I don't need that particular student. So I don't want 44. Similarly, I take some 55. If he is having some backlogs, sir, here you are not listing the backlogs, just you are verifying whether there are some backlogs or not. If there are backlogs, that is, there are some records in the result of the inner query, then I will display the outer value. Hope you understood it. So that is the meaning of exist. Clear? Let us discuss one example on exist, sir. Find the details of boys who got more percentage than at least one girl. Sir, the same example we have already discussed with the help of some or any keyword. Now we are going to discuss alternative way of writing the same question using exist. Okay. So you need all the details, right? Instead of all the details, for better understanding, let us write IDs. Okay. So select SID from student. I have only one table, sir, so that I will use for 2 times. So student A. So select A dot SID. Fine. Where exist. Fine. Up to here is fine. Now what you need, sir? Find the details of boys who got more percentage than at least one girl. So what I do is, here I will display the girls. Girls whose percentage less than a percentage. Whose percentage less than a percentage. Then automatically here if I have some girls, that means this fellow is intelligent than at least one girl, maybe more than one girl also. Suppose I don't get any girls, what does it mean, sir? All the girls dominated that particular fellow, then I don't need that particular fellow. So right, so in the inner query what we do is, here you need to write a query which will display the girls. So select, you can display anything, sir. Select star from student. First of all, she must be girl, sir. Where, let me give the number B. 1 minute, sir. Where B dot 6 equal to girl, and B dot percentage is less than A dot percentage. So here I will get some details, or the girl's details, who got less percentage than my boy, right? That is the story, sir. Sir, please observe it. Here we done a small mistake that at first I also not noticed. Select A dot SID from student A where exist. So it will consider the first rule number 22. If I got some girls, it will display Sudha. Second, it will consider Sita. Again, it will verify the same story. But I don't want the girls. I want to verify only for boys. So where A dot 6 equal to boy and exist, right? So you can write it, or if you want, you can specify here also. Better to specify outside. So that is the story about the exist keyword. Now let's go to one more, sir. Find the details of all students who registered all courses. Who registered all courses? What I do is, we will do one thing, sir. I will take one rule number. I will take one SID here. Okay. Then in the inner, what I do is, first we write all courses. We write all courses. From, I need to subtract minus courses by SID. Courses by my SID. That is, the courses which were registered by SID, or let me write clearly. Courses registered by SID. What will happen, sir? If this fellow has registered all the courses, then all courses minus here, this will become empty. Whenever the student registered all the courses, it will become empty. Whenever it is empty, I need this fellow. For exist, whenever it is not empty, it will be displayed. For not exist, whenever it is empty, it will be displayed. So what I do is, outside the bracket, I need to write simply not exist. Not exist means what, sir? If you write only exist, whenever there are some records in the inner brackets, SID will be displayed. Now, whenever there are no records in the inner brackets, I need that student. So that's why I am writing not exist. So now we need to describe it. Select, you can write star or you can write some any star. Select star from student. Yes, where not exist. All courses. How to get all courses, sir? Select course name. I think we given same name for column and table also. Don't confuse with that. Select course from course table. Minus. Instead of minus, what is the keyword, sir? Minus. Courses registered by SID. How to get it, sir? Select course from where you are having all these details, sir, in register table. Are you selecting all the courses, sir? No. Where, let us give the name, where r dot SID, that is the registration student ID, must be equal to the SID of the outer table. Hope you understood it, right? So we are selecting the details of the student. I will take one SID. From all the courses, I will subtract the courses registered by this fellow. If it is empty, what does it mean? That fellow registered all the courses. Hope you understood it. Sir, this yellow brackets is only for our understanding purpose. They are not part of our SQL query. Don't confuse with them. Or let us leave them. Right? So this is all courses minus courses registered by the student. Whenever this is empty, that means the student registered all the courses. So whenever he listed all the courses, it will be empty. So that's why I am using not exist. So let us do one previous question, sir. A relation schema for a train reservation database is given below. Passenger, passenger ID, passenger name, age. Reservation, passenger ID, CAS. I think it is class, sir. Reservation class, I think. Then TID, ticket ID. Which PIDs are returned by the following SQL query for the above instance of the tables? Oh, they given the table, sir. Sir, whenever they given the data in the table, it's very easy. Select passenger ID from reservation. Fine, where class equal to AC. So I need the passengers who registered or who reserved AC class. That is the first story, sir. So who reserved AC class and exist. There is one more, sir. Select star from passenger where A is greater than 65. Where A is greater than 65. And passenger ID equal to reservation dot ID. That means 1 minute, sir. Just give me 1 second. So PID has selected, sir. That PID must be equal to passenger ID. Okay, fine. And age must be greater than 65. Sir, instead of exists, you can simply write the general query also, sir. Just to confuse us, they give an exists keyword. Let us discuss it. So first, let us consider from reservation table, right? Where is the reservation table? This is my reservation table. It will consider the first zero. Zero passenger ID it is considering, sir. What you will do is whether the class equal to AC or not. Yes. Then second one. And exist of what I need to have, sir? Select star from passenger where age greater than 65 and this ID must be equal to here. What is the ID? 0, sir. 0 is here. 0, fine. Age greater than 65, sir. It's not greater than 65. So no records. When no records, will you get it, sir? No. Right? So let's go to the second record. 1. Is it AC, sir? Yes. And exist. Select star from passenger where age greater than 65 and passenger ID equal to 1. Passenger ID 1, sir. Age greater than 65. Yes. So I think we will get 1 Rahul 66. I am getting 1 record, sir. So it will be displayed. Then the next one is 2. Is it AC? Yes. And exist. Passenger ID must be equal to 2 and age must be greater than 65. Yes, I have Saurav. So this will be also displayed. Then the next one is 5. The first one, is it AC? Yes. The second one, exist. Age must be greater than 65 and passenger ID equal to 5. Do you have any passenger ID 5, sir? No. So no records. So this will not be displayed. Then the next one is again 1. Is it AC? No, sir, it's not AC. So we don't get it. Then 3. Is it AC? Yes. And exist. Exist, right? Fine. So ID must be equal to 3. Age must be greater than this one. So we get 3 Anil 69. So it will be displayed. So what are the records displayed, sir? 1, 2, 3. What is the question they asked, sir? Which PID is returned by the following SQL query for the above instance? I think we got 3, right? Then why we have this one? Check it. For 0, we don't get anything, sir. Just give me 1 second. For 0, it's not correct. For 1, it's fine. For 2, it is fine. 5, we don't get. 3, Yeah, I think I done some data entry wrong, sir. If this is the relation, then surely three records will be displayed, sir. 1, 2, 3. Because for 1, please verify A is greater than 66. For 2, A is greater than 67, sir. For 3, A is greater than 63, 9. All these are also AC. If this is the data, we will get 3 records, sir. Maybe somewhere I have done, instead of SC, I have written AC, sir. But if this is the data, we will get 3 records. Okay. Please make a note of it. Let's go to the next one, sir. Consider the following relation schema. Employee, emp ID, emp name, emp department. Employee ID, employee name, employee department. That's it. Customer, customer ID, customer name, sales representative ID. That is something like this employee is the representative for this customer and rating given by this customer, right? So sales representative ID, yes, the same. Sales representative ID is a foreign key referring to emp ID of the employee relation. Assume that each employee makes a sale to at least one customer. What does the following query return? Select emp name. Sir, from the outer table, he selected one employee name. Then he will enter into the table. Sir, please look at this. This is not exist. That means in the inner query, I should not get any records. Select customer ID. You are displaying the customers. Which customers you want, sir? Sales representative ID equal to employee ID. So he is the representative of this customer. That is the first one. And C rating. I think this is the symbol for not equality, sir. So suppose the employee name is Sudha. He is the sales representative for this customer and he got some bad rating, something like not good rating. So whenever an employee getting some bad rating by a customer, then that customer details will be here. Whenever some details are there, I don't want that employee. Whenever there are no details, what does it mean, sir? He don't get any bad rating. Then I need that employee, right? So what you get, sir? Name of all the employees with none of their customers having, with all their customers. Name of the employees for whom all the customers given good rating. Okay. Let me write clearly next slide, sir. Suppose you have considered Sudha, 22 Sudha. After considering it, internally you are displaying the customers who given bad rating for Sudhakar. Who given bad rating? I mean, not good means bad rating only, right? And here it is not exist. So here I have a bad rating record. Then I don't display this Sudha. Suppose I take in 11 Sita. She don't have any bad record. That means there are no records. When no records, I will display Sita. That means for Sita, all the customers given good rating. That's it. So name of all the employees with all their customers having good rating. That is the story about this question, sir. The next one. Nested queries with unique keyword. Find the details of the students who registered exactly one course. Select star from student. Where so suppose I written like this. select the courses. So first let us take one record from the student and let us go to the courses table. Where is the courses table? Register, right? So select star from register. But I need only the registration courses by this fellow SID. So where, let me write register r.sid equal to s.sid. Sir, suppose if this is my answer, what will happen, sir? You take one rule number 22 and you go and list out all the courses registered by 22. If I got some courses, I will display 22. I will take 33. If I get some courses, I will display 33. But the problem here is, if he registered more than one course, then also you are displaying it. But now I don't want like that. I want the students who registered exactly one course. That means here the count must be unique. Then what should I do, sir? Instead of exist, simply write unique. That's it. The same story, sir. It will take one rule number outside. It will go and verify internally. If you got exactly one record, it will display this 22. Otherwise, it don't display it. Now, let us discuss one question. Consider the following relation. Cinema, theater, address, capacity. Fine. So, we have only one table, sir, in which theater, the address and the capacity. Which of the following option will be needed at the end of SQL query? Select P1 dot address from cinema P1. So, you are displaying the address of the theater, sir. Fine. Such that it finds the address of the theaters with maximum capacity. So I need the theaters with maximum capacity, right? If I need maximum capacity, then select star from cinema. Okay, instead of star, they give an address, sir. P1 dot address from cinema, where I need with maximum capacity, sir. Where P1 dot capacity. There are two possibilities, sir. Equal to, I will write the max capacity of all theaters. Max capacity among all theaters. Or what I do is the same, greater than or equal to, I will list out all capacities. Then it must be greater than all capacities. Since all capacities on the outside, I need to use all. That's it. Right? So these are the two possibilities, sir. Let us write in next one. What is the first possibility? Select P1 dot address from cinema P1, where P1 dot capacity is equal to, here what you need, sir? Max capacity. How to get max capacity, sir? Select max of, let us suppose the second table name I given again P2. The same table, sir, but we given different names. Max of P2 capacity from cinema P2. Then here I will get some maximum number. Suppose the maximum number is 1500. Then if the capacity is equal to 1500, it will be displayed. Instead of that one, what is the second possibility, sir? In the bracket, I need to list out all the addresses for all the capacities. Select P1 dot address from cinema where P1 dot capacity is greater than or equal to of all. Here I need to list out all the capacities. How to list out all the capacities, sir? Select P2 capacities from cinema P2. That's it. So what is present in our answer, sir? It is max only, sir, but it should be equal to any or equal to all. You can write anyone, sir, but it is equality only. But for both of them, it is greater. So it is not. Then coming to next one, we are listing all the capacities. Then it should be greater than or all because it is maximum capacity. So the first one is our answer. Hope you understood it. Let us discuss one more, sir. The relation book title price contains the titles and prices of different books. Fine. Assuming that no two books have same price. No two books have same price. What is the following SQL query list? Select the title from book. Select title from book. So you are displaying the title, sir, but before displaying, what you are doing is where here I have some condition. This must be less than 5, right? This must be less than 5. So what you are having in this, sir? You are selecting count. So select count of star. That means you are selecting number of records. You are selecting number of records. What are those records, sir? From the same book table, okay, you are listing the books whose price greater than my selected book. So you suppose I selected data structures book here. Internally, I will list out all the books whose price greater than my data structures price. If that list, that is the number of records in the list, if it is less than 5, then I will display DS. Okay. If it is equal to or greater than 5, I don't display it. Suppose if it is equal, sir, what does it mean? There are 5 more expensive books than DS. 5 more expensive books than DS whenever it is equal. If it is greater than, that means more than 5 books are expensive than DS, but they are given strictly less than, sir. What does that mean? Maximum 4 books will be expensive than DS. So that means you are displaying the top 5 expensive books. So the titles of 5 most expensive books. Hope you understood it. If it is equal, what does it mean, sir? There are already 5 expensive books than DS. If it is greater than, more than 5 books are expensive than DS, but it is less than, that means maximum of 5 books are expensive than DS. That means DS will be in the top 5. Right? So this is about nested queries and SQL, sir. In the next session, we will start transaction management. Thank you.